many of the properties, when we talk about addition properties of real numbers or multiplication properties, that they are, the result is very much the same. So if I add two numbers, it's one unique real number. Same thing with multiplication. Commutative, a plus b equals b plus a times b equals b times a. Addition and multiplication in these cases are always going to result in that way. Starts to get a little bit more complex once we get to the identity property, because the associative property is essentially the same. A plus b first in parentheses plus c is going to be the same even if I take b plus c, then add a. It's always going to be the same. No matter what the order of operations, the associative property holds true. Same thing with multiplication. A plus b, or sorry, a times b times c is going to be equal to b times c, then times a. You're going to get the same number no matter what. It's one of the associative properties of multiplication. But where it changes is the identity property. The identity property states that there exists a unique real number, 0, such that when I add it to any number, so a plus 0 or 0 plus a, the result will be a. But in multiplication, the identity property exists with the number 1. So meaning a times 1 or 1 times a will result in a value of a. Now, the inverse property is very different when we're looking at addition and multiplication properties. Because if I multiply a times its inverse, or sorry, if I add a and its inverse, the result is going to be 0. But in multiplication property, if I multiply a number times its inverse, the result will be 1. Right? So the inverse property result is different with multiplication as it would be for addition. Now, the one that you will see in many cases is what's known as the distributive property, and that's when you have any number times two values in parentheses. You multiply that number times both of them, resulting in a times b plus a times c, as seen here, which it falls under just properties of real numbers in general. The final slide is just referring to a few properties of equality. So the reflexive property, if I have two identical values on either side, they're equal, symmetric. If a equals b, then b equals a, stands to reason. The one that is often used is this transitive property, where, well, if a equals b and b equals c, then a equals c, just via the transitive property. And the final property of equality is substitution, meaning that if a equals b, then I can replace a with b, and I wouldn't be changing anything in terms of equality or whatever the value of an expression is. So a can be replaced by b without any consequence.